today's lesson, linear equations in two variables, we'll be taking a look at three different forms of linear equations. We'll use those to write equations for linear lines and to also graph them. The first equation is slope-intercept form, y equals mx plus b. We saw this previously in the last video, and we'll know that m is your slope and b is your y-intercept, and that can be written as 0, comma b, where b is your number. Hopefully it's an integer. The second form is standard form, and that looks like the following: ax plus by equals c. And we also talked about this previously. A, b, and c are usually going to be integers, and a is usually going to be positive. This form is useful to find the x and the y-intercepts, as it's easy to plug in the zeros and then solve for the missing variable. And finally, the last form that we're going to be taking a look at this section is point-slope form, which is y minus y1 equals m times the quantity x minus x1. M is going to be your slope, and x1 and y1 will actually be a coordinate point. Notice that y and x will not be. That's just part of the form of the equation to help set the other points. We're going to take a look at a few examples where we're going to decide what form we're going to use. The first one, we're going to write an equation for the following in standard form, and then we'll graph. So the first one is given a slope 2/5 and a point 3, -4. Now usually the names of the forms help you decide what you're going to use. Here we're given a slope and a point, so what we're going to use is point-slope form. Y minus y1 equals m times the quantity x minus x1. y1 will be -4, so it's going to be minus a -4. Our slope is 2/5, and our x1 will be the 3. So we plug that in, and this right here is technically an equation for the line, but what we're asked for is to put it into standard form. So what we'll do is we'll kind of simplify and combine terms. Y plus 4 equals 2/5 x minus 6/5. I'm going to get rid of the fractions right away by multiplying the entire equation by 5. So 5y plus 20 equals 2x minus 6. I want to bring the 20 to the other side and the 2x to the left. So negative 2x plus 5y equals negative 26. And then I want a to be positive, so I'm going to negate the entire equation to give me 2x minus 5y equals 26. Now, graphing given a point and a slope is quite easy. What you just need to do, again, this is a rough sketch, you might want actual graph paper. You're going to plot the point 3, -4. And then use the slope to go up 2, and then to the right 5. To be about here. And then you just need to connect the 2 points. The next problem that we're given that slope is 2 and the point is 0, -3. Now here we're given a slope and a point, so you might think point-slope form. But if we take a look at what the point actually is, the first number is 0, which indicates this is a y-intercept. Since that's a y-intercept, all we have to do is use slope-intercept form, y equals mx plus b. The m will be 2 for our slope, and then b refers to the intercept, which would just be -3. So we just plug it in, and there we have an equation for the line. Y equals 2x minus 3. If I put it in standard form, I'm just going to rearrange it a little bit. and negate it, 2x minus y equals positive 3. Now, again, when we're given a slope and a point, and especially a y-intercept, this will be fairly easy to graph. All you have to do is put the y-intercept down, 0, negative 3, and go up 2 units into the right 1 unit. Connect the line, and you now have your linear line on the graph. The last one we're going to look at, given 2 points, negative 2 and 2, 6 and 1, 4, there's not a specific form that you can directly plug in 2 points. But what we do know is we do know that we can take 2 points and we can find the slope. So we'll take the 2 points, we'll calculate the slope, 4 minus 6 over 1 minus negative 2. That gives us negative 2 over 3. And then we can pick a point. And since we have a slope and a point, we'll use point slope. It doesn't matter which point you use, as long as you are consistent. You can't take an x from one point and a y from another. Let's take 1, 4. So it's going to be y minus 4 equals negative 2/3 times x minus 1. I'll distribute. I multiply by 3 to get rid of the fraction. I'll bring the x over to the other side and the 12 to the right. So 2x plus 3 equals 14, and there's our standard form. Now, given 2 points, I don't really need the slope to draw the line. So negative 2, positive 6, and 1, 4. I put those down and then connect, and there is my line. We actually have one more. We're going to look at what it would be like if we have parallel and perpendicular. Parallel, we talked about that we want the slope to be the same. Parallel, it needs to be opposite reciprocal. So one of the things we're going to do is if we have a point negative 8, 3, and we want to see an equation that's parallel and then perpendicular, is we'll want to put the equation into slope-intercept form. That way we'll be able to see exactly what the slope is a little bit more clearly. We don't care about the y-intercept, only the slope. So we know that the slope of this line is going to be 2/3. So if I want one that is parallel, I want to use the slope 2/3 and the point negative 8, 3. And if it's perpendicular, I want to take the opposite reciprocal and the point. For both of these, I'm going to use point slope form. And then calculate it from there. We'll distribute, multiply by 3, bring x and y to the same side, bring the 9 over. So here's an equation parallel to that, going through the point. And then we'll do the same thing over here. We'll distribute. This will multiply by 2 as well. 2y minus 6 equals negative 3x minus 24. Same sort of thing, bring my x and y's over, bring the 6 over. And this would be an equation to the line that is perpendicular. We're going to take a look at two quick word problems. The first one says, suppose there is a flat rate of 20 cents plus 10 cents a minute to make a call. Write an equation that gives the cost y for a call x minutes. So basically, we're getting charged 10 cents a minute, and we know that there are x minutes. So basically, I'm going to multiply x by 0.1, and we know that there's a flat rate of 20 cents. So no matter how many minutes, I'm going to have an additional 0.2 or 0.20, 20 cents. That will be the total cost of my call, which would be y. So there's an equation that represents making a call for 10 cents a minute with a 20-cent flat rate. And the last example, the percentage of the U.S. population 25 years and older with at least a high school diploma is shown in the table for selected years. Find an equation that models the data. Well, basically what we can think of this, each one of these as an ordered pair. Year representing x, percent equaling your y. And since we don't technically have a slope, we can calculate one given the points. And to even make it easier, we can start 1940 as our initial year and then count the years past that. So each one of these is getting altered accordingly. The easiest thing to do is to start with a y-intercept, 0, 24.5, and then pick any other point and then do your slope. So let's just say that we'll use one maybe down here so it's a little bit, it's not so close together. 52.3 minus 24.5 over 30 minus 0. 27.8 over 30. And then I can plug this into my equation. Y equals, and we'll round that, 0.927 x plus 24.5. Now, if you chose any other points, your slope will be a little skewed or a little bit different because these are not collinear points, but it should be approximately the same thing.